Hello everyone, my name is Tinn, a PhD student from the University of Manchester, and today I'm going to give a talk about a targeted radio pulsar survey of redback candidates with MeerKAT. And this talk is based on the paper that we just published this year. The key points and the main thing is that we used MeerKAT radio telescope point to the Fermi unidentified gamma ray sources with the redback characteristic, and we discovered 3 new MeerKAT pulsar, and one of the systems has the eclipse all over the place, and another system is a system with a very massive neutron star, which is very interesting. Before I move on to the details, I would like to thank my supervisor, my collaborators, and everyone who involved in these discoveries. So let's start with what are redback. So redback is the type of spider pulsar, which is MeerKAT pulsar binary system with very compact orbit and irradiated small companion. We can categorize spider pulsar into 2 main groups: black widow with an extremely small mass, and redback with a small companion mass but larger than black widows. And because there's a MeerKAT pulsar in the system, so we expect that, okay, maybe this MeerKAT pulsar also produce a gamma ray signal. And instead of pointing our telescope randomly to the sky, we position it to the specific location where we think we can find pulsar, and that's when Fermi gamma ray sources come into play. The thing that we are interested in this survey is the unidentified gamma ray sources. Because these unidentified gamma ray sources, some of them have the gamma ray pulsar-like characteristic, and because of that, there's a mini study that observe them in optical and in X-ray, and they can find the redback light curve, and they propose, okay, maybe these redback candidates. And here are a few examples of the people and the team that observe on this target. One thing I want to point out is that our team, led by MeerKAT in Manchester, also working on this object as well. Okay, because we use MeerKAT and other people already talked about it, I'm going to skip this slide. And in order to do the survey, we select 6 redback candidates. These are Fermi unidentified gamma ray source with redback characteristic, and there's no radio or no gamma ray position at that moment. We observed this source twice at L-band and twice at UHF. And once we found them, we asking for the follow-up observation using either telescope in order to confirm them, and also ask for the short timing campaign in order to time and understand their system. So in order to do that, we have this elevation plot. This is the elevation of 6 candidates. The bigger region here represented wind pulsar is in the front of the companion based on the optical information we have from previous studies. And the thinner line here is when pulsar is at the back of the companion. So by doing this, we can maximize our opportunity to find pulsar. And then we discover 3 new MeerKAT pulsar. I won't go into the detail of this pulse profile, but the thing I want to show you here is that, well, although they are MeerKAT pulsar, but they can have very distinct profile. The thing I'm going to focus more on in this talk is about their ecliptic behavior. This is the phase coordinate plot. On the x-axis here, you have the orbital phase 0 to 1 mean 1 orbit. Phase 0.25 mean when pulsar is at the superior conjunction. So basically, blocked by the companion or gas around that region. So that region is pre-expected. So maybe you cannot see pulsar. The color represent the observation at different band and different telescopes. The darker color with dot is when we can see pulsar in our observation, and when the lighter color without dot is when we cannot see pulsar in our observation. And when we look at this plot, over 955 here, you can see this gray region as well. And this gray region is the eclipse that actually happened and occurred in our observation. So that's why we know for sure that eclipse happening. In this particular source, we can also see the mini eclipses in this shorter observation here as well. So by looking at this pulsar, we think, okay, maybe this one is just a, let's say, typical eclipsing binary where it had been blocked around phase like 0.1 to 0.4 region with some mini eclipses. And if we look into this one, JOA38, probably my favorite one, because this one, when we first detected here with MeerKAT, we see, okay, there's an eclipse here, but when we observe it again at UHF, it turned out that we can't see pulsar throughout the observation, which is very strange because it's at the same phase and it's at lower frequency. And after that, we try to observe this source for 2 years. This is like 1 year, and this is like another whole year, and we cannot detect this pulsar again until August last year. Okay, kind of turned back on again, so we have MeerKAT observation August, September, and October, and also a few more past observations that seem okay, turn back on again. And because of that, people think, okay, first thing maybe this one can be a transitional Mexican pulsar or TMSP, which is a special type of pulsar that when you look at it, sometimes you think it's a radio Mexican pulsar, you get the radio signal, but another time when you look at it, you cannot get the radio signal, but you get the X-ray signal, which is in the low mass X-ray binary state instead. And this source also has been proposed as a TMSP in 2017 because of the X-ray information. However, we do not have the X-ray data. We cannot access the X-ray data easily in our case. And when we look at the gamma ray flux, it turned out that this one didn't increase in gamma ray flux, so it's difficult to see because the original TMSP 1023 has the increase in both X-ray and gamma ray flux when it changed the state. So this one still, yeah, maybe it's TMSP, maybe it's just an extreme case of increasing binaries. And the last one, J3333, this one is, we cannot see any eclipse in our any of our observation, maybe some detection undetected here and there. So maybe this one not experiencing any eclipse, or maybe it's a bit difficult to say at this point. Maybe we need more data around this region. So when we have that, we do pulsar timing, and thanks to Marta and Paolo, who helped and teach me about pulsar timing, we managed to get the radio ephemeris. And after that, we sent the radio ephemeris to Colin and Lars to doing the gamma ray timing and gamma ray search. And here is the plot from Colin and Lars, the orbital variation throughout the 15 years of Fermi gamma ray data. The gauge scale represents the log likelihood, the ray region represents 95% confidence interval. Thing that I'm going to show you next is the gamma ray pulsation. Once we get the timing of the system, we also get the gamma ray pulsation here. And one thing that I want to tell you is that this thing is kind of like whole circle thing when we start with gamma ray. Right? We have the gamma ray source, like unidentified source. We then have the other optical and X-ray information, and after that we do radio search and we do radio timing, and once we get the timing, we send it back to gamma ray, and they able to find the gamma ray pulsation in the end. So I think, yeah, we need a lot of more data in order to do stuff. And for the next part, once we have all those information, we also do neutron star mass measurement. We use the information from radio timing. We use the radio velocity from previous study with, that they used in the optical spectroscopy, and we use the gamma ray information because this system also has the gamma ray eclipse as well. That's why we can constrain the inclination. And here's our result for JOA38, the one that eclipses all over the place. It turned out that it's a very quite low pulsar mass, about 1 solar mass. For 955, the one with normal eclipse, have, let's say, about the normal neutron star mass. And 2333, although we cannot say much about in terms of eclipse of this one, the mass of it is like quite large. It's about 2 solar masses. And I already talked about the detection, the discovery was about the undetected redback candidate. So one thing that came up into our idea is that, okay, maybe they're just a radio quiet, maybe their radio beam pointing away from us, that's why we didn't detect any signal. Or maybe the system also experienced some kind of, like there's maybe a lot of gas in the system, maybe experience something similar to JO838, so that's why we didn't detect in the end. As you can see, JO838 is kind of like eclipsing all over the place, that's why it's very difficult in the normal survey. That's why we need this dedicated 1 hour long targeted survey in order to find it. And for future work, we want to find more and more pulsar. We also have a Fermi shallow survey with MeerKAT that we observe unidentified Fermi source with pulsar-like gamma ray characteristic, but not the redback candidate for 10 minutes. We also have the expanded spider survey. This time not just redback, but we also include black widow candidate as well. Lastly, we have other follow-up observation with other radio telescope and also optical telescope, like the one that I'm going to talk about tomorrow. And yeah, I'm gonna finish everything with picture of our team. Thank you.
Very good. We have a question here from Vishnu.
Yeah. I haven't checked like in terms of the ratio, but the one that we just see like here is one that have a more, let's say, more confidence in terms of capable candidate, something like that.
In the back, Faisal?
No, when we look at the two band, it's always really. So I think there's some strategic things
This
here.
was plotted in a frequency dependent curve. Do you see some bands that are missing during the eclipse as well?
No. I mean, when during eclipse, it has been blocked and. But I'm not sure I'm really like understanding what you mean. Like for example, here we have the like eclipse in Thailand and not in Eurasia, but that's a different observation. But in the same observation, when it's eclipse is bloop, just gone.
Okay.
No, we haven't done any.
I think just since there's no more questions, I would like to make a comment here. So if you go to slide 11, no, there's one with the gamma ray detection and also with the
Gamma ray detection.
yes, these slides and the next one. So I find this absolutely remarkable that you find a pulsar close to 2024, and then using the gamma ray data, you're able to trace these varying or kind of random orbital variations all the way to the start of the Fermi mission in 2008, and then in the next slide we get like every single rotation of the pulsar in that time. I mean, this is quite an achievement there. I mean, I'm saying this because I know how much of this pain it is to solve these things in the radio if you have these random orbital variation. And we often have to deal with this when looking at redbacks. So this is, I think this is outstanding work. So, yeah.
Thanks for calling at last.
Yes, yes, I know it's done. It's really outstanding stuff. So, thank you very much.